Ready in 5, 4, 3.
You're listening to Coding Blocks, episode 45. Subscribe to us and leave us a review in iTunes, Stitcher, or more using your favorite podcast app.
Visit us at codingblocks.net where you can find show notes, examples, and more.
Send your feedback, questions, and rants to comments at codingblocks.net. Follow us on Twitter at codingblocks, or head to www.codingblocks.net and find all our social links there at the top of the page.
You were supposed to mix it up, man. I'm pretty sure that tonight it was supposed to be dub.
I think that's what I did last time.
I thought you did dub. Oh, maybe.
We're going to say www.
Okay, there you go.
Codingblocks.net.
You sound so old right now. Nobody does the dubs. It's a new generation.
What do they do now?
Nothing.
Well, we haven't got their introduction, so I don't even know who's talking right now.
That's right. It's just codingblocks.net. You can do that too, but we'll put the dub on there for you because we are old school. So
if we were cool, we'd have a .io.
You know, I've thought about that.
Oh yeah,
we could call it Codio. Anyways, all right, so with that, I'm Alan Underwood.
I'm Joe Zach,
and I'm Michael Outlaw. Or am I?
Yeah, and first, we wanted to thank you for your patience. We had a couple of rough audio issues the last couple episodes, so we appreciate you guys sticking with us. And we've already started a little stumbling on each other, so we're off with a bang. But thanks for sticking with us, and you guys are great.
And hopefully you can hear Joe this time. That would be a plus, I think.
Yeah, so sorry about that. It really did not. The audio, unfortunately, wasn't up to our normal standard of what we would prefer.
Yep.
So, we want to start off with some reviews here. We want to start off on a high note here.
I think we should.
All right. So we had some amazing reviews as always. We love it when you guys do this. It definitely puts a smile on our face. And this is unfortunately, I have to read some of these again. So you're going to have to bear with me if it's your name that I totally butcher. But I think I picked the easy one, so I'm sorry, Alan. So in iTunes, Hedgehog, which we actually got twice, was interesting. And then, I don't know, I think I should just call this one Thomas. Theogoramus AI. Does that sound pretty good? I guess. Close. Button 1992. Jonah John Lee. Undead Code Monkey.
Love it.
Z McKinnon, Hillside Cruiser, Dib Jib Jub, and D DuRose. I think I got those at least in the ballpark correct, maybe.
Yeah, that wasn't terrible. So on ours, I've got the Stitcher reviews, and we've got PCH Teaspoon, maybe TSP, not sure.
Raphael Tablespoon.
Yeah, no TSP, man, that's teaspoon.
What a horrible acronym, anyway.
We've got Raphael H, CK142, the Middleman 124, and Local Juiced. And by the way, I am now the Californian motorcycle driving dude with a headscarf.
I read that. I did read that somewhere. And, the funny part about that, though, is, and I don't mean this as a negative to the author of that comment, but when I hear Alan talk, no part of his voice reminds me of California.
Come on, y'all. You know I'm from California.
I mean, but then at the same time, I don't know. Maybe we all sound like, well, no, I guess we don't all sound like we're from California because you were the only one that got the comment. But yeah,
I totally want to be that guy, though.
Okay.
Yeah. So just so you guys are in on, we got a review. Thank you, Local Juice, that basically compared Alan, or so the mental image of Alan mapped to a California motorcycle riding guy with a headscarf. Unfortunately, Alan's head might have outgrown that scarf a little bit after reading the review, but we do appreciate it, Local Juice.
After reading the review? No way, man. He outgrew it before he ever read that
I don't think you guys heard, but I got a 4 on the Stack Overflow thing.
Oh, right. There was that. Yeah.
So, again, thanks everybody for the reviews. They seriously make our days.
And then, did you read this whole thing though? Like where he says, "I picture Alan as a Californian motorcycle dude with thick eyes." That part is important.
Yes.
And a headscarf. So,
Oh man, I laughed for 5 minutes after I read that. It was awesome.
It was good. Now I
Yeah, so
understand
feel
why
free-
he said, he made some comment about like, well, thank me after you read it or something like that. Read it before you
Yep.
thank me. Now I
Well,
understand.
feel free to show me some love, guys. My head's shrinking over here. I don't know if I want to know what you guys think I look like and what vehicle I'm driving on the freeway in California.
I think that should actually be the poll. No, not a poll. Everybody should leave their comments. If you haven't seen our picture on our thing, there should be like a thing describing. This is a bad idea. We should.
Well, I mean, you keep saying things so much. I'm trying to get like, what is he talking about?
I was thinking like leave a comment on this particular episode, but now I'm actually scared. I feel like this should be bypassed.
Well, I can tell. Like, I don't mind telling you after some of the feedback we got. I don't want to know what people think of me because that could not go in a good place. That could go wrong quick.
So we're saying a meanest caption contest.
Oh God, here we go.
We're gonna turn our site into Reddit.
Oh God,
All right.
the internet is cruel.
So we got a little other piece of news here.
So there was this amazing article that I saw. What was it? Yesterday that came out, and I don't know, Joe, if you had already seen this, but do you like SSDs, Joe?
Oh, I love them.
Well, how would you like to have a 60 terabyte SSD? You heard me.
That would be fantastic.
60 terabytes. This beast from Seagate is coming out. I think it said 2017. 2017. And it is supposed to be for business use. But it got me excited because I was like, oh man, that means that it's not too far out then before larger capacity drives like this come out for consumers. And here's the best part of this thing too, is that a 60 terabyte, a single drive, 60 terabyte drive dwarfs not only all the other SSDs that are out there, but every hard disk that's out there too.
Yeah. That's amazing. The part that I'm excited about is you just recently got the Samsung 950 Pro, right?
God, it's amazing.
So for anybody out there that is not up to date on SSDs and all that kind of stuff, the 950 Pro Samsung is amazing because it's the M.2 form factor. But the reason why it's so impressive, though, is it uses the PCI lane. So it is super fast. I think it's got like 2.5 gigabit per second reads, and I don't even remember what the writes are. They're like 1.5 gigabits, but it's stupid fast. It's like 5 times faster than regular SSDs that are already fast, right?
It does depend on which one you get, though. The 512 does outperform the 256.
Yes.
Which, if you think about it, it makes sense because just imagine from a size thing point of view, right? The same size, thing, okay. One of them is double the size of the other, so that means the one that's double the size, all the bits are crammed in less space. So it makes sense that it would be able to read and write faster from that point of view. But also at the same time, when I say that, though, I'm like, well, darn, that's thinking of it in like a mechanical sense where it's like you got to go further. But whatever, man. It is true though that the larger capacity one is faster than the smaller one.
Well, temporal locality matters. It sounds like we've been doing some researching on caching and hard disks.
It really does, and we're going to be diving into that. So, but we still have a few more pieces of news. But I was going to say the exciting part is Samsung's not the only one doing the M.2 PCI stuff now. Plex Store is joining the game, and some other ones. So hopefully the price of those things will start dropping soon.
Yeah. So just to follow up on those numbers, though, here's the 512 gig version versus the 256 gig. And these are obviously both from Samsung. Sequential read. I don't even say this, 2,500 megabytes per second for sequential read.
It's insane.
And then on the 256 gig model, it's 2,200 megabytes per second. So a difference of 300. Yeah. And then on the sequential writes, it's 1,500 megabytes per second for the 512 and 900 for the 256. So, not half, but also a lot.
Stupid fast. Either which way, just crazy fast.
Yeah, I mean, I'm totally in love with that thing. It is amazing.
So in the next piece, one thing that we mentioned last episode was I think Outlaw just kind of randomly thrown out Ready Player One about being a good book, right?
Yes.
So I went online and I was like, okay, I need the Kindle version. And I started reading it. Well, unfortunately for me, I fall asleep when I read at night. So, I was getting 10 pages in every night, and I'll finish that book in the year 2050. So I tried to go and give Amazon my money and buy the Audible version, but for whatever reason, I could not get it to take my payment. So I was like, you know what? I'm going to check my library. So here's a pre-show tip for you guys. Check your library. A lot of libraries now have a digital section where you can download audiobooks for free. And you can even download Kindle books for free. And you can get all kinds of stuff for free from your local library. So I tried to give Amazon my money. They rebuked me. And so I was able to download the audiobook for free. It's amazing. If you have not listened to or read Ready Player One, man, it's really enjoyable, especially if you grew up in the era of the 80s with playing video games like we did. Man, it is a ton of fun.
Wesley Crusher for president 2016. I'm writing him in.
Awesome. And then the last thing, I mentioned this on Twitter and got quite a bit of Twitter love on this one, is we decided that, in an upcoming episode, because a lot of you guys really enjoyed when we went through the book, how to become a programmer or how to be a programmer, advanced, intermediate, all those. We got a lot of good feedback on that. So we decided we were going to pick up Clean Code. Each one of us got a copy. We're going to spend a couple episodes on that here in the near future, and then we'll be doing a giveaway. So, be prepared when a new episode hits. Listen to it, because probably within a couple weeks of that, we'll be doing giveaways of at least 3 copies of this book. So,
yeah. So if this is a book that you were already interested in, this is a good opportunity for you to be lazy and just wait.
Yep. Clean Code by Robert Martin, right?
Yeah,
Uncle Bob. Uncle Bob.
All right.
I don't like saying Uncle Bob.
You don't?
No, I mean, I'm sure he likes it, but it just feels awkward, doesn't it?
I don't know if he
I've
does
never
like
met him.
it.
I don't know.
Maybe
him.
he does.
It sort of rolls off the tongue, though, man. Uncle Bob.
I haven't read one way or the other if he likes that, so maybe we're assuming.
Well, that's his Twitter.
Oh, it is.
Yeah, Uncle
you're
Bob
right.
Martin.
Yeah.
So he must like it.
He must. Or either that or it's grown on him. Maybe it started out in the beginning. Like, that's the thing. Maybe in the beginning it was kind of like, wait, why are you calling me that? And then over time it was like, okay, fine. I kind of
whatever.
I'll accept it.
All right, I'm uncomfortable with it, like most things.
I'm just going to go ahead and say it now. No Uncle Mike. I don't want to hear it. No Uncle Outlaw. None of that.
What about Grandpap?
Oh, now those are fighting words. Come on, California.
Yeah,
Let's
I know, right?
bring it over here, 90210. Let's take this. Let's go. I'll show you, Grandpa.
That's amazing. So what's our topic of the evening?
Something about
tonight?
turtles.
No turtles. Are you guys familiar with the turtle story?
No, not at all.
Turtles all the way down?
No.
Yeah, I don't remember the whole story offhand, but basically it had to do with like a preconceived notion or a myth that somebody thought that the world was basically balanced on the back of a turtle, and that's how we all managed to kind of stay afloat. And somebody asked, well, what's underneath the turtle? And the person who gave the original answer, it's turtles all the way down. And it reminded me of caching, which is our topic of tonight, where basically there are so many different layers of caching that it just blows my mind. It's incredible to think that this whole world of computing is really so heavily built around caching to the smallest level. And so I just it reminded me of that little story. I'll find a link for that.
I don't get the turtles all the way down though. Like what they mean that?
Well, I think he means
turtle on top of a turtle on top of a turtle on top of a turtle.
Well, like there's cache on top of cache on top of cache.
Right.
Yeah, it's totally irrational to think that there's turtles all the way down. I mean, it doesn't answer the question, so it's irrational. But yeah, it's just the idea that it just keeps on going down forever. Just cache upon cache upon cache.
I kind of feel like until I hear this story, though, Joe, tell me a story.
All right.
Looking, searching. Unfortunately, it reminds me of Horton Hears a Who. I don't know if you guys ever saw it. I have little kids.
I remember that one.
Yeah. It reminds
right.
me of that. We're a planet floating around in somebody else's, like, backyard.
So caching or short-term memory.
Yes. So, what is it? What is caching? Why is it important? What do we use it for? Why are we even talking about it?
Yeah, and there's a couple definitions out there, but the shortest one, so the one that was my favorite, is one that I wrote, so it's probably crappy, but it's basically, I think of it as just storing a subset of information for faster retrieval. So it's a smaller portion of the whole data of everything you're working with, and you save that smaller portion in a smaller spot and a more easy to access spot.
Yep.
Sure, I'll take that definition.
And it sounds so simple, right? I mean, really, that's what it is. It's such a simple concept. Just
Well, it also, like, as he was saying that, though, like, you kind of have to wrap your head around that, because he said storing a subset of information for faster retrieval. And it's the subset part, because then I was thinking, like, well, if the browser caches, that could be caching the entire web page. And it could be. But that entire web page is only a subset of the internet.
That's all true, and all of those are examples where caching does come into play. And actually, that's a great example there with the web request. Like, you're just using the internet, using something like Chrome, you type in, to go to www.codingblocks.net, then just the different layers of caching is mind blowing to me. Your browser caches data, right? So this if you've ever had to clear your cache or clear your cookies, or clear your cache. But also, just the DNS name is cached, right? So your computer keeps a local cache of common websites or websites that you've gone to before, so it doesn't have to go look that up and do that action over and over again.
Well, actually,
your ISP does it.
In the case of Chrome, though, since you specifically mentioned that, Chrome has its own IP management, though. So that wouldn't be. But I understand what you're saying. Like, your computer does keep like a cache of DNS entries, is what you're getting at.
If you've ever flushed your cache, then you know all about it. Good old IP config. Then the ISP, like if you're Comcast or Bright House or whoever your internet provider is, does the same thing. They keep copies of the data that's commonly requested closer to you, so they don't have to go all the way to Coding Blocks or Google, and they can just serve that up for a closer location, like physically closer in most cases. And even then, once we forward that request on, you may not even be going to our codingblocks.net server. You could be going to a content delivery network like Akamai or CloudWatch. Azure's got one too. And even then, we do a lot of caching. Mm-hmm.
Well, I was going to say also Cloudflare.
CloudFront. Azure's got its own.
Well, I was thinking it's Cloudflare specifically because it's a free one. Mm-hmm. So it's really easy for a lot of people to use. And we were using it, but I think we stopped.
It was actually slowing us down horribly. But, the thing is, though, it's the same. What he's saying is, like, there's caching used at every layer of a web page coming down. Like, we're only talking about a web page, right? Like, anything, if you go to codingblocks.net, all this stuff is happening all the way down. And actually, it's sort of in reverse order, right? You've got your CDN, then you got your ISP, you got your DNS, your browser.
No, he had it right. This is the simple request of making a web request, right? So that web request starts on your computer, so in your browser, and the browser looks at its cache, and then as a result of that, it says, okay, let me do a name lookup, and do I already have this DNS entry cached? If so, I'll use that. Otherwise, I'm going to go and query a DNS server, which who knows if it's got it cached or not, and then after I do that, then I'm going to start making the web request outside of this computer, which goes to the ISP, who might have it cached. And if not, now I'm going to actually go to try to get to the website, but that website might be fronted by a CDN, such as a Cloudflare. And if that CDN doesn't have it, then I'm going to actually go to the website. And then once I actually hit the website, then the website itself might have its own caching layers that it's doing. So instead of making additional queries to the database over and over and over for like maybe static content or content that doesn't change often, maybe that content is already cached at the web server level. So,
and real quick, I want to back up on the CDN thing because this was new to me a couple of years ago. Like most of the other things that we just mentioned there are fairly common for programmers. If you've never heard of a CDN, all it really is a place to put things that don't change much, that you want to be closer typically to whoever's consuming that. So
That's not exactly the way I would phrase it.
well, let me finish my thought, and then,
Okay,
then we can revisit.
Here I go.
So like for instance, images on a website, right? Like if you have a bunch of images on your website, typically you don't want to serve that up from your server because you're using your server to serve up things that really don't change much. So it doesn't really make much sense to take the processing power from your computer that you might need for more important things. And additionally, when you do content delivery networks, they can be cached closer to regions of the world. So all your images you could have in Europe, so that when somebody requests your website from Europe, all the images are served up from a server closer to them, or if they're in Asia, something closer to them. And so you put your images out there on these fronted networks so that when somebody makes a request to get that image, it's not actually coming all the way back to your server. It's being served up from what they call these edge nodes that are closer to where they are. And so that cuts down on the amount of network traffic that you have direct to your server. It cuts down on the amount of processing your server's doing, like Apache or anything else. Like if it's having to serve up a file, it's kind of wasting time. And so that's one of the ways that you can do that. So that's a content delivery network.
Well, specifically as it relates to the edge caching too, though, because it's physically closer to the client, then there's less latency involved in them making the request and retrieving the request. Now, here's why I say that like your definition of it being content that doesn't change isn't entirely accurate. And that's because like my initial experiences with CDNs was all about video. And in the case of video, we would push content out to multiple CDNs, and the CDN's job is as soon as they got it, they would then blast that out to all of their edge nodes. But that video, they were only keeping maybe I forget how it was set up. Let's say a minute or two's worth of video. So maybe I'm doing a horrible job of explaining this. Let's say I was streaming a live event. Okay, like some sporting event,
the
right?
Olympics are going on
okay,
right
the
now.
Olympics are a great example. That was never one of them, but let's just use that as an example. So if we were streaming the Olympics, right, and that might be the entirety of that stream, as a live event, maybe let's say an hour-long event, right? But we would be pushing it up in segments. The encoders were pushing up segments of this live stream. So like think of, a bunch of individual movie files, right? And those were getting pushed out to the CDN, which the CDN would then push it out to the edge nodes. But that CDN would only keep, let's say, 10 of those segments. So 10 of those movie files. And then and now this might be some dated information, but like if you were to do streaming for iOS, live video streaming for iOS, and the way the QuickTime wrapper would work is you would basically say like, okay, you're going to get these number of streams coming in, but the names would constantly roll from the encoder, right? And so basically it would kind of like just loop around. Let's say if it started off as segments 1 through 10, right? So it'd go 1, 2, 3. So your iOS device starts playing it from 1 and then goes to 2, 3, 4, and then when it gets to 10. If you were to actually look at the file in a text view, you could see the segments changing, but they would change back in order. So then the first one listed would be 11, and then it'd go. So maybe it starts off in the file, like if you were to look at the metadata of the file, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 3, 4, 5, 6, 7, 8, 9, 10. You see what I'm saying? Mm-hmm. 11, 12, 13, 4, 5, 6, 7, 8, 9, 10. And so that way, depending on where the user came in, they could, let's say, start from whatever the oldest was. So like we finished off at 4 would be the oldest one. So, but the point is that content was aged off of the CDN edge somewhat quick. So it wasn't exactly what you said about like something that's not going to change often. It depends on the usage of what you're doing. So specific to video, at least, it's going to change.
Yeah, I see what you're saying.
If it's a live stream. Now, if it's not a live stream, then that's a whole nother.
Yeah, I mean, I was thinking more like images. Like you'll even see like JavaScript files from Google or something, right? Like you'll see static Google. Actually, I think it's static.google.com if you look at a lot of their stuff. And that's their content delivery network. So that basically, instead of hitting their Google servers, they just have this file sitting out there that basically just shoots back the text. So, but at any rate, that was a little tangent. I just kind of wanted to, for anybody that had never really heard of a CDN, that's what it is.
Yeah. I mean, to your point, there's a whole, well, no, that's not exactly the same thing, though. I was thinking of like the hosted libraries that Google has for like Angular or jQuery or something. I mean,
probably using a CDN, but
yeah, behind the scenes. But I was thinking it was more exposed because I know what you're thinking of. You're thinking of CloudFront.
CloudFront is for AWS. Google also, like if you use their Google Map APIs, behind the scenes, it'll make calls out to static.google.com for images and that. And those are their CloudFront or their CDN type files. So, yeah, I mean, it's pretty cool. If you've never heard of it, check it out. But back to our regularly programmed schedule.
So why don't we just cache everything then? Because so far, the way we've said it is it sounds amazing. It sounds like there's already a ton of it. And, why wouldn't we just do it all the time for everything ever?
Well, in general, the faster it is, the more expensive it is. And the more expensive it is, the smaller it is. And as you mentioned too, temporal locality, the size and physical location of these things matter. So it matters that your RAM is close to your CPU. You wouldn't want that in, say Africa or even across the room from you because it really does have a big impact. And it's kind of funny because we usually don't think about stuff like that in computing. You just think about networking connections and you don't really think about the physical location of the server. But when you're talking about performance, that stuff really has a big impact.
Now, just to be clear, though, when you say that fast is expensive, we're talking dollars.
Yes.
Right?
Yes. Yep.
And one of you guys threw a quote in here somewhere, and I'm trying to find it. We might have actually pulled it out, though. What are the two hardest things in programming?
Oh, right. Well, yeah, I mean, that was going to come up later. But, yeah, cache... how to cache things and how to name things. And I know I'm messing up the quote, but that's the gist of it, is that the two hardest things in computer science are how to cache and when to invalidate the cache, and then how to name things.
And off by one errors.
Right. Oh, right.
That's not hard. That's just everyday life.
What's the two hardest things? Forget it.
Yeah, and cache invalidation is a good point. We're not going to talk about it too much tonight because it's like a whole other subject. But yeah, a lot of the caching things that we're going to talk about tonight actually are situations where we do have a good situation for knowing when information is old. But if you're talking about like a distributed application or let's say a situation where you've got like multiple nodes of a NoSQL database, then just knowing when your data is out of sync is a big problem. This is another reason why we don't use cache everywhere, just mostly everywhere.
Right.
Yeah, and so for tonight, we wanted to just take a look from a different perspective than we normally come from on the show. And we wanted to talk about these things from the bottom level up. And we thought this is kind of a cool way of thinking about things. And in particular, there's a really well-known set of numbers, commonly referred to as latency numbers, every programmer should know. And we've got a link here in the show notes that points to a gist from GitHub. But this is actually, these numbers have been floating around the internet for a long time. I think somebody from Google, maybe even Bill Gates invented these numbers. I don't know where they came from, but they've been floating around for a long time. And so if you Google for this, you're going to see them everywhere. But we found a nice source that I really like, and the comments are really good on it. So we'll have that in the show notes. But what we're going to do is actually start at the very bottom turtle, if you will, and work our way up.
What do you want to cover some of these numbers in the latency numbers first, though?
I think we should at least talk about them because
at least a couple of them.
Yeah, some of them are really hard to even.
I wish that at least some of us hadn't looked at these. It'd have been interesting to like take a guess at these.
Yeah, I took a little snapshot out of the ones that I thought were kind of the most relevant because I think the list itself has around 20 items. So I kind of snipped out the ones that I thought were like the most important. And it got some relative speeds, and then I've actually taken some notes that compare these things to like numbers that we can actually realize. So it basically translates these things to seconds, minutes, hours, and so it's a little bit easier to talk about.
Well, let's go for it. Give us some of them.
All right, well, let's go ahead and start at the very bottom. So the L1 cache. L1 cache is a really, it's the quickest thing we have. And it basically sits right next to the CPU. You can stack data in there. The CPU knows how to get it. And this is actually something you can't even modify with assembly. This is just total hardware. The CPU uses this stuff. It loads stuff in, takes it out, and it operates ridiculously fast, like 0.5 nanoseconds fast. And I know what you're thinking. That? Yeah. So I looked this up. 0.5 nanoseconds is about, it's roughly the amount of distance that light travels in 6 inches. So it's the speed of light for 6 inches.
Wow.
Yeah. So that's 0.5. So 1 nanosecond is roughly 1 foot light. Why can't I say this? It's 1 foot of light traveling. Help me out here, guys.
No, you're doing a great job. This is like when I'm trying to say some of the names for the reviews. Yeah. I'm enjoying this part.
This is Tell me the story. That light travels. Light travels 12 inches in 1 nanosecond.
That's impressive.
So this is how far it travels. I'm waiting.
And I can't do it. All right. I am totally confused now. But anyway, it's really freaking fast.
This is how long it takes light to travel in 6 inches. Right?
Yes, exactly.
Okay.
Hey, and to put this in just what we were talking about, expensive. All right. So the new Skylake newish, the Skylake i7 6700K processor, the level 1 cache, which is what we're talking about right here, it has 4 slots of 32 kilobytes.
Right. So it's small cache.
It's tiny cache. All right. This is a brand new high performance processor, right? And that's for the
4 times 32K.
Cache. Yes, 4 by 32K, but it also has an L1 data cache that is the same 4 by 32K. So that's kilobytes, right?
Like nobody's used that as a measurement since like the 80s.
Right. So that's when we talk about it's expensive, that's what he means. Like if they could put, a gig of that stuff on here, you'd have a computer that was basically doing quantum computing, right?
Well, I was going to ask, why can't I just get my whole motherboard to be L1 cache?
Right.
You can have a little bit of corner for the CPU, but I want the rest of it just be L1 cache and just everything operate that fast.
By the way, when was the last time you guys ever heard of kilobytes used for anything?
Never.
My internet connection sometimes.
So, I mean, putting that, like, that's almost hard to imagine, right? Like you can create a text document with very little in it and it'll be bigger than 32K.
Right.
So that's kind of to put it into perspective there.
And also, if you did get, say, a whole motherboard made out of this L1 cache material, it also wouldn't be nearly as fast as this 0.5 nanoseconds because temporal locality. A big part of that speed is that it being really close, like on the molecular level to the CPU. So the physical size is actually a limitation here.
Yep.
I wonder, now I'm kind of curious because you said 4 times 32K, right?
Yep. That's 128K. That's a Commodore 128 back in the day.
Yeah, so I'm super curious now. I'm trying to find, okay, let's say, hold on, I don't want to tell you what this is just yet. And we're not going to use any text editor, so we're just going to go straight VI on this bad boy. And let's VI, and then call it that, and then paste that bad boy in and save it. And then, now what did you say the number was? 128, you said, right?
Okay, 128 kilobytes.
So my curiosity is the preamble to the United States Constitution larger than all of the L1 cache on a Skylake processor? It registered in it no, that would be in bytes. So maybe it's not so bad. Okay, I'd take that back. That would be in bytes.
Depends on your encoding.
Right.
Yeah, that's why I was like, because at first I thought like it was automatically showing me in K, and I was like, oh, wait a minute, that's amazing. It's actually bigger, but no, it's not.
All right, so what's the next big number you had?
Yeah, that was in bytes, here? 328 bytes. So it's a lot smaller. Okay. Well, that didn't make it as much fun as I was hoping for.
Oh, dang.
Okay, can we erase that part?
We can, but we're not.
Where's the undo button on this show?
Too lazy.
Dang.
All right, so what's the next number that you had dog marked as or earmarked as?
Yep. So I wanted to call out the L2 cache. And I mean, all this, we should mention that all these numbers are like rough approximations. Things are different based on all sorts of factors, including your computer, the temperature, the humidity. I mean, who knows? All sorts of factors. But the next thing I wanted to mention was the L2 cache. And some computers do go up to L3, L4, and there's all sorts of other stuff. But I did want to mention the L2 specifically because, as far as I know, all modern computers have them. But also, just want to show how big of a jump it was. And the L2 speed clocks in at 7 nanoseconds.
So 14 times slower.
14 times slower. Yeah, just for a little bit further on the chip.
And to also put that one into perspective using the Skylake processor, this one is quite a bit bigger. It has 4 blocks of 256 kilobytes. So 1024, right? So, I mean, it's almost 10 times the amount that they put on the L2 than they had on the L1.
Yep. And just like L1, this is not stuff that you can mess with in assembly. This is all managed by the CPU itself. So you're out of it.
Yep. It has its own custom algorithms. Out of curiosity, did you have an L3 on this list? Because I don't see it on this page, so I'm assuming probably not, right?
Nope. It may be in the numbers that I pulled it from originally. I can check that, but I don't think so.
Okay, well, I'm going to...
I didn't see it.
Yeah.
There's no L3 or L4 in that the article, the GitHub article that Joe was referring to.
So here's what I want to point out is on the i6700K processor, if you just look at regular like retail type specs on it, it says it has an 8 megabyte cache. That is referring to its L3 cache, which it's awesome to go ahead and tout that because that's kind of a cool spec on your processor, but that is your slowest by far. So we got to figure if your L1 was traveling at 6 inches, the same as the speed of light is over 6 inches, right? That's pretty impressive. Then the L2 was already 14 times slower, which makes me believe that L3, being that they put on quite a bit, right? Like 8 times the amount of the L2 cache. That's probably another order of magnitude slower, like maybe 20 times slower. This is just a guess, but you know.
Yeah, I guess it depends on the chip, but yeah, I think that's a good approximation. I did also want to mention, I should have written this down now, Jeff Dean and Peter Norvig, who both are pretty big wigs over at Google. These are the guys who originally published these numbers.
Cool. So what was the next big number you had on there then?
Yeah, so skipping the cache, I wanted to talk about RAM, main memory.
Hey, just one question though, and maybe this is going to sound stupid, but it's still on the same die though.
Yep.
Like, so going back to Joe's comment about proximity, like, you know, if your memory was on the other side of the room, how that would affect the increase the latency. But this is on the same die as the cores and the L1 cache.
Mm-hmm. It matters.
But yet it's slower. It's slower access speed.
Might be a different type of memory and might also be, I mean, different construction, I should say.
I don't know if you've looked at the CPU lately, but that little thing is just a piece of magic. I don't even understand how that thing can work because when you look at it, none of it makes sense. It's just a solid thing, and yet there's supposed to be something inside of it that does some stuff.
Yeah, it's pretty amazing when you think about it.
It's literally a black box.
But yeah, I mean, I guess that's the whole point, though, is just moving it, you know, a few millimeters when it's that small and electricity's going through it can make a huge difference, right?
Well, now L4 is a different type of material.
I don't know. It's not listed on 6700, so I don't know.
Well, yeah, and I think they even go. I think it even goes on from there. Like different architectures can go further and further. I found some pretty cool pictures, but it's just over my head. So, one of the pictures I'm looking at right now has got a shared L3 cache. So it's actually got all of these processors, and they share this L3 cache. And so it is a lot bigger, but it's something that they can use to kind of pass information between each other.
Interesting.
It's a pretty cool idea.
Cool. So you said your next one was memory, right?
Yeah. So this is RAM. And they had a couple numbers in there, so I wasn't really sure what to use. They talked about having memory access, and then they talked about reading a megabyte sequentially. And I just don't know what memory access means. Does that mean, you know, the overhead associated with reading anything, or is that, I wasn't sure which number was what I typically think of when I think about reading from memory. But in either case, it was a big sway, which is why I wanted to call it out. So depending on whether it's memory access or reading a megabyte, which is huge, from memory, it's the difference between 100 nanoseconds and 250,000 nanoseconds.
That's a pretty big jump. Even though a nanosecond is still hard to really conceptualize because it's, 10 to the negative 9?
Yeah.
Wait, you're talking about the difference between reading from the memory versus L1 or L2?
Yeah. And also, even with the memory,
okay.
There were two numbers for memory. It was kind of confusing. So it's somewhere between 100 nanoseconds and 250,000 nanoseconds, which just compared to the L2, it's either 14 times slower or 35,000. No, not 20, 35,000 times slower.
Well, if I got to take my pick,
L2.
then I want the 100 nanosecond main memory.
So I think to your point, Joe, looking at this chart, I think the main memory reference is just getting to that slot. If you think about like a hash lookup type thing, I think it's just getting to that slot. But then to actually read a megabyte sequentially from memory, which is as fast as you can do, because if it's sequentially in memory, then that means it's actually, all in line, 250,000 nanoseconds. So
I got confused about that. Sorry.
No, you're good. Go ahead. What were you saying?
It's random access memory. So I think that the way like physically the RAM is laid out is it doesn't really matter about sequential or not. So that was kind of confusing to me too, but I'm just kind of showing my ignorance. I don't really know how this stuff works, but maybe that's why I'm so fascinated by it.
Yeah.
Well, maybe this is why we are not in the hardware business and we are software developers.
I mean, if you look at it, and this is a little bit out there, but if you look at benchmarks on like SSDs, I think there's a site called Ssd Benchmark that has a lot of good information on it, but they'll show you the difference between sequential reads or random reads and that kind of stuff. And so I think it really does boil down to, if you have a smaller file, typically it's stored sequentially on the disk. I would imagine the same thing happens in RAM, but as soon as something grows over a certain size, it can't cram it all in contiguous memory slots. So then it starts pushing it around on the drive wherever it can. And so I think that's what we're looking at here, is this read 1 megabyte sequentially from memory means, like, literally, if I have a contiguous block of memory and I grab it all out, it's 250,000 nanoseconds. And that compared to your level 1 cache reference at 0.5 nanoseconds, that's an order of 500,000 times difference, right? It's incredible. That's pretty massive when you think about it. And
we think of sorry.
No, go.
We think of RAM as being fast, right?
Yeah, I was getting ready to say, do you guys remember the days when they were like, hey, you want to upgrade your computer? Add some more RAM to that thing, right? Like that's what the things were back, 10 years ago. Now they're like, hey, add an SSD, because that's what's really slowing you down. Who knows what it's going to be in the future.
But you're making the point
we're going to get there.
You're making the point about sequential, though. Normally, sequential read writes are faster than random read writes.
Yeah, that's what I was saying.
Because I don't know. For me, the analogy is always easiest to think about a spinning hard drive, where you can actually see, or not see it, maybe see it in your mind, but not see it in real time. But you could envision the head moving across the platter, right? And if it's able to just read everything it needs or write everything it needs sequentially, then it's not having to move back and forth. But if it's doing a bunch of random reads or writes because the disk is fragmented, for example, then you're losing time and latency just for it to move the head to the correct spot.
Yep, it'd be bouncing all over the place. You'd see that arm moving back and forth, as opposed to just getting everything in one row.
Now, you mentioned the SSD benchmark, and I'm not sure if this is what you were referring to, but I did find ssd.userbenchmark.com. I'm not sure if that's the one that you were referring to.
No.
It has, it looks like a wealth. I'd never heard of this site, and I only searched for it because you said something just now, and there's some very interesting comparisons here for SSDs.
Yeah, there's
I'll
some
put a link in
ones.
the show notes.
Yeah, we'll definitely put that in there. So what was your next one up? So we've already determined that just reading sequentially, the fastest type of read from memory, is 500,000 times slower than your L1 cache reference. What's the next one on the list?
Yeah, this one was surprising to me. The next one is network. However, there's a couple of caveats there because once again, this is kind of confusing to talk about because there are a couple entries for network, but this in particular is actually sending data. So this is just, stuff going out on the wire, not getting it back in. Oh no, I'm sorry. I ended up writing something different down. This particular set of numbers I captured, we do have that number, but the one that I wrote down here is actually local data center. So the amount of time that it takes to go out over your network card, your NIC, and come back and basically a local data center. And what was really surprising to me is that this was faster than hard drive, SSD, or spinner.
That is interesting. I see that.
Well, that could make sense to me though, especially like what kind of networking are we talking about here? Are we talking about? Well, what I'm getting at is, were we talking about fiber connections, or are we talking about, twisted pair?
Yeah, it's got to be fiber because they're talking about inside a data center.
Well, even if you were talking about twisted pair like Ethernet,
you can get 10 gigabits on that.
Yeah, I'm calling that as well. Can you? I know that like the routers, they usually have fiber interconnections to get those 10 gigabit speeds from router to router. If you're talking about like a serious enterprise router,
you can buy server motherboards that have 10 gigabit NICs on them.
Really?
Yeah. So yeah, you can get twisted pair with 10 gigabits. Now the distance that'll travel is probably
short.
not very far, but yeah. So the data center trip for send and receive is faster than an SSD. But that's faster than a sequential read of 1 megabyte on the SSD. So we're talking about just a simple request, I think, a round trip.
Wait, was it faster than SSD or just faster than a hard drive? I thought he said hard drive at first, right?
Both. Yeah.
Oh.
Yeah. So this is actually not related to caching. I was just really surprised by this, but it does kind of give you an indication of just how fast the network can be if you've got these guys in the right spot. So you can see how using something like an application server, like a Redis or something to cache something in your data center could be really beneficial because it really is comparable to hard drive speeds.
And it's only, if you've got the same numbers I do here, it's only it's 2 times slower than the read from memory. So that's really not that slow, right?
Oh, wow. So I just found this 10 gigabit per second PCIe card over standard Cat 6A cabling.
Yep.
And there's your RJ45 connection right there.
Yep. I'm sure that the length of that run can't be very far at all, but still, I mean, that's impressive for a twisted pair set of wires. So now we've seen that the data center, and I'm imagining that's just like a packet send and receive. Like that's probably nothing major, right?
Yeah, probably not a megabyte. It didn't actually say, I don't think, the size.
Right. So
probably like in an ideal world, jumbo frames are not on.
Yeah, there's going to be all kinds of things coming into play there. So what was your next number that you had marked down?
Yeah, so 2 times slower than my memory and 1 million than L1. So we're getting the big numbers. And the next was SSD.
Well, we already have to abbreviate our numbers, so that's an idea, like just how much larger our numbers are getting.
Right.
Oh yeah. Yeah, I spent some time trying to find like almost like a, like a planetary, like a solar system picture of these guys, just so you can get a sense of scale for how far out these bigger items are. But I couldn't really find a good visualization that I liked.
So,
but yeah,
you just said though that the SSD that was next on the list. And it's 2 times slower than the round trip to the data center. But this is for a 1 meg read sequential, right?
Yep.
But, I mean, in fairness, though, if we're talking about 10 gigabit per second Ethernet, then, okay, sure. I could see that because not even that Samsung 950 Pro writes at 10 gigabit or reads at 10 gigabit.
Right.
Unless you were talking about rated, but you're talking about like a single drive here.
Yep.
So,
yep. But, I mean, that's still impressive, though. So what this one came to was 1 million nanoseconds, which is 1 millisecond.
Yeah.
1 millisecond. That's crazy.
Yep. And 2 times slower than network, so it's 4 times slower than RAM and 2 million times slower than L1 cache.
That is unreal, man.
So now I don't feel so great about that 950 Pro that I just bought. I want to. Can I trade that in? I just want like a truckload of L1.
Well, it's kind of funny. Like, one of the things I was thinking about, especially comparing the SSD and the spinner, is we can see, and we'll talk about in a second, the spinner is 20 times slower than the SSD. But that doesn't mean that going and getting a solid state drive is going to make your computer feel 20 times faster, because there are so many layers of caching that you're only improving basically the slowest parts of that, where the cache is missed and you have to go and fetch that from the hard drive.
All right, now I see a return to Amazon in my future.
Yeah.
I don't feel so good about that thing.
Yeah, so what was the next one on your list then?
Well,
so we just hit the SSD. What goes down from that one?
Oh, you have something, Michael?
Well, I was going to say, because you already covered spinning, yeah?
No.
I thought we just did.
Nope.
Okay, let's do spinning.
Okay. Yeah. So first point is get your boss to buy you an SSD, because it is 20 times slower than the solid state drive.
Says
and
the
40
guy
million
who
times
uses
slower
a
than
spinning
L1.
hard drive.
Yeah. Boss, if you're listening, you need an SSD. But yeah, as we just mentioned, it doesn't mean it doesn't mean you're going to be 20 times more productive, because there's all sorts of other things like the RAM, like the caches going on, like your network stuff. And so, yeah, getting a SSD isn't going to make you 20 times more productive.
But an interesting side story here, because we've actually done this when we stood up our website. We were kind of low on RAM, remember? And we ended up basically telling it to use the SSD underneath it as a swap for memory. And so that kind of tells you how good that stuff is now. Yeah, it's quite a bit slower than your memory that's directly on the motherboard with it, but these things have come so far that literally we've had page swaps for hard drives forever for Windows, because back in the day you couldn't have 8 gigs of RAM or whatever, and so it would constantly page things to and out of memory to your hard drive, and things would be just crazy slow. Nowadays you can basically do the same thing with an SSD, and you really don't even notice the performance difference.
But so you cover these numbers: 20 times slower than an SSD, 40 times slower than the L1 cache. This just goes back. 40 million. How did I forget that? 40 million times slower than L1 cache. This just goes back to my supporting argument that I just want a truckload of L1 cache, and I'll just create one giant RAM disk out of it, and I'll just never shut down my computer. I'll have it on a UPS, and that way I'm safe.
Yeah, you got no persistence there. So yeah, don't turn that baby off, or you're screwed.
Yeah. Well, hey, so let's just take a moment if you don't mind, before we continue on with this awesomeness. Because you know what, dear listener, if you haven't already put a smile on our face, today would be a great opportunity for you to do that. And head to www.codingblocks.net/review, and you'll find links to either iTunes or Stitcher, whichever one's your favorite, and do leave us a review. We greatly, greatly, greatly super duper appreciate it. Even if you want to say how Californian Alan is, if you want to talk about his thick eyes and his headscarf, it will definitely make him giggle. But we would greatly appreciate it. And if you have already left us a review and you're like, oh, not this part of the show again, we are so super appreciate those reviews. We go back and look at them, and it puts a smile on our face every time we see it.
And it is really your way to give back to us. I mean, more than anything, that is our one ask. So
yeah. I mean, we've had people say like, hey, do you have a Patreon? I'd give you money for a beer, but hey, consider this your way of giving us that beer.
Until we get the Patreon up, and then you'll have to do both.
Show me the money.
Yeah, wow.
I'm just saying.
This took a turn quick, guys, and I am sorry. I did not see that coming. I probably should have.
You changed, man.
I accidentally set that up, and I apologize now.
I ain't too proud to beg.
Yeah, I see. So while we're in this like little break for a moment here, you guys, I hope, haven't cheated, and I would like to go over the results of the last poll.
Hold on, let me get there.
Because nope, because this one I think struck a nerve with some people. So the question was, what is the hardest part of landing the technical job? Right. So your options were the job requirements, dealing with recruiters, the technical interview, racism, sexism, ageism, any discrimination of some form, location, or just getting the call back about the job, period. Now, Alan, you're not cheating, are you?
I'm not.
You seem really busy on your computer over there.
I'm playing with a link that we're going to share in a minute.
All right. Which one of those do you think is the one?
I'm honestly going to go with the location.
Location.
Yeah, I think that's like the biggest barrier for people. Like, people try to live where they can afford a bigger house or whatever, and that's usually counter to actually finding a job in tech. So that's mine.
Okay. Oh, okay. I think. Okay, I took that. I misunderstood you. You're saying that you think that they'll go to a place that they can afford so that they can get the most bang for their buck, which might be a place more remote than where. Okay, I'm with you now.
Yes.
Joe, what's your pick?
Yeah, part of me thinks the ageism, sexism, racism, but I think that I'm gonna have to go with location.
Oh, really? You're both going to take this? Okay. So then, Price is Right rules. You guys know it. Okay. Give me a percentage that you think that one was the winner by. And if you go over, it's an automatic loss.
33.
33% from Alan. And he's sure this time because notice last time he stumbled and he changed his vote and then he was like, oh, man, I was so close.
Yeah.
What say you, Joe?
27%.
27%. All right. Well, here's the deal. So, again, you're both wrong.
Doggone it.
But this time, Joe's more right.
Oh, but wait. Was it location?
And I'm pretty sure he cheated. It was location was not the number one.
Oh.
And I actually felt a little vindicated because my point last time during that discussion was that the hardest part about getting the job was that you just had to get called back, period. And that's why it was so important to have those bullet points on your resume, such as, Stack Overflow. Here's my information that you can find out about me on Stack Overflow. Here's my GitHub, things like that, right? Just because that'll help your your resume to stand out so that someone can see information about you before they even bother to talk to you. And that was the number one choice by the listeners, just getting the call back, period. Now, this is why I say that I think Joe might have cheated there, Joe. Didn't you? Come on, admit it.
Nope. I'm in touch with our listeners.
Right. That's okay. There you go. That's how you super duper know he was cheating, because location was 27.1%. It was the number two. Well, it was tied for number two with the technical interview, which was also 27.1, which is why they're tied. And I forgot to mention that just getting the callback period won at 29.2%.
Oh, so they were all super close. Those three.
Those three.
Almost 100% of everything.
Yeah, those three were definitely the top ones. Now, I was actually kind of surprised about this one. The racism, sexism, ageism, discrimination of some form was nothing.
But in all fairness, we didn't put on there, hey, put whether you're white, Caucasian, or black, or Asian.
Well, the color of your skin has nothing to do with your age.
Well, but
or
racism,
your sex.
sexism. So we didn't do male, female, white, black. We didn't do any of those. So if everybody that took it was a white male, or 99% of the people, so
okay, fair enough.
I feel like we're missing some data points there.
But even still, though, okay, yes, I totally understand. But that's why I had discrimination. That's why I added into it just discrimination of some form. Right? It doesn't matter what the discrimination is; it could just be of any form, and that way, because like ageism can affect anyone. It doesn't matter.
Totally.
Right?
Good point.
But I was actually really surprised to see that one didn't get any pick. So, and that's also a very subjective one too, though, because the other ones, you only might have a feeling that might have been what kept you from getting a job after you've left an interview or something, right?
Right.
Whereas, just getting a call, like if there's a job that you want, right? And you can't get the call back, then you're going to know right away, like, that's the hard part that I'm facing right now, is just getting them to call me back.
Right.
Right. And then, so along that line, we also talked about the favorite meetup ever, or at least, my favorite meetup ever, which I went back and I dug up the information on this because I was so super curious and wanted to share it. So this was with the Atlanta JavaScript meetup, and I can provide a link to the specific one, but the title of it was Hacking Interviews. And it was with Nick Larson. That was the developer from Stack Overflow. And Sam Lawrence was the interviewee for the meetup. And it was fantastic. And we can include that information if you're curious to see it in the show notes.
Yeah, I'm surprised the ageism, sexism, racism wasn't higher. It might say more about our demographics, but that's the poll results. Do you guys have an idea for the next poll?
Oh,
I've got a list here. I've got one. If you want me to shoot it out there.
Yeah,
shoot
go
it
ahead.
out.
Okay, so here's the question. Don't answer it.
Okay.
If you were stranded on a,
if I do answer it though, then I get to taint the jury, right?
yeah, which you may want to do.
Okay. Just want to
That
make
is
sure
an
I
option.
understand the rules. Sorry.
Yep. Yeah, you can cheat if you don't. Yep. You
Oh.
can cheat. It is cheating.
Let me clarify.
So the question is, if you were stranded on a desert island and for some weirdo reason you could only take one programming book with you to better your skills on the desert island, which one would it be? And we'll have a couple options there, but we'll have stuff like common books like Clean Code, Code Complete, Design Patterns, Pragmatic Programmer, maybe a couple others. But which programming book is basically, do you think, is the most important?
That's a good one.
Which one has the most pages? Because if I'm stuck on an island, I'm going to need to start a fire. So I'm going to need some kindling. Because my main concern is going to be getting off that island.
Hey, you know what, though? This is good fodder, though, because this particular one might decide what our next purchase is in our next giveaway. So think about this one a little bit, and don't just do it because you've already got it at home, right?
Hey,
pick one that you really think.
I wanted to bring this up too. This is 45, so episode 43 was a couple episodes ago, and we had talked about the imposter syndrome, and apparently that was another topic that really hit, well with people, right? They too had experienced this, and we weren't the only ones. We weren't alone. But there was this great feedback that we actually got today. This great comment that, I guess being a guy, I just didn't have the perspective of that this commenter did. So Carol wrote in and she said that she imagines that the reason why, I had said in the Wikipedia article that this affected women more than men, or that's at least what the study was in. Found for women, I believe it was. I forget exactly how it was worded, but and Carol imagines that it hits women more than men just because of the environments that they grew up in, and their abilities being questioned from simple statements such as like, well, girls can't do math, to various other stereotypes that are constantly being thrown at girls, and even when people might not realize that they're doing it. And, I thought, well, that's a great point that, I just didn't have the perspective to even consider that. And I thought that's a good reason why maybe that is the reason why it was more often in, women than men.
Yeah.
Or at least in that study.
Yeah, I wanted to point out too, she actually left a really great comment on episode 42. So yeah, Carol is killing it. And you guys can comment too and read some really intelligent and awesome comments as well on our website.
Yep. And that's www.codingblocks.net/episode 42. And then her recent one was on episode 44. So
43.
43. My bad. So yeah, definitely go up there, check those out, respond. We'll do that as well. We just haven't because we're preparing for tonight's podcast. So we will get to it. And then
So with that, let's get back to these numbers. So next, in terms of we've already gone 40 million times slower than the L1 cache.
Yeah. Like, how can it get any slower than that? There's the internet. And so we talked about data center, and it was really quick, surprisingly. So another number they tacked on here at the end is basically a rough gauge of internet speed. And I think they went California to the Netherlands and back. And there's some numbers on that. You can read an article. But they just basically wanted to give you an example. And all sorts of stuff comes into play here. We talked about CDNs. We talked about ISPs. We talked about all sorts of stuff that really mess with this. But just for a broad picture of what's going on, we're looking at 150 million nanoseconds.
I feel
like
we
we across
should
the
stop
globe.
measuring in nanoseconds.
Yes. And yeah, we're gonna get to that. Yeah, so that is 7.5 times slower than spinning disk, which is still pretty awesome, but 300 million times slower than L1.
yeah, that's insane. And this is actually easier to put into reference of something that we understand, right? It's 150 milliseconds. So if I'm correct, and I always jack this up, that is basically 10 of those would give us a second, right?
I didn't know we were going to do math.
I can never remember this. How many? All right, so 1 second.
Well, this seems odd though, because like if I go into Google and I say like, hey, 150 million nanoseconds in like minutes or something like that, like I'm getting crazy results.
Yeah, so 150 milliseconds is roughly 1/10. So 100 milliseconds is 1/10 of a second. So I feel better that I didn't do that totally wrong. But yeah, so to do that request, the packet, just one packet from California to the Netherlands and then back to California was 1/10 of a second, a little slower than 1/10 of a second. And that 1/10 of a second is 300 million times slower than the L1 cache. And we went from top to bottom of this just to give you a perspective of it. But the importance of it is really what? Like, why does any of this matter? Like, we kind of need to explain what that really is, right?
Yeah, we need to bring it back to caching.
Well, hold on though. Was that for the internet one? Did they say like what the speed was for that? I mean, are we talking about like Google Fiber?
Nah,
Are we talking about like my internet connection where we're measuring K?
Nah, they didn't give any specifics.
Yeah, and there's no way even for them to really know. I guess you could do a trace route to see that what it's hitting, but it's really hard to tell even what's happening there. So it's just a real rough approximation. But what it does tell you is that if you can skip that call to the internet and hit RAM instead, you're going to be saving 150 million nanoseconds or whatever it is.
So in other words, this is a gauge on how to determine what parts of your application you should focus on for improving.
Could be.
And so going back to our How to Be a Programmer series, right? When we had talked about, when to refactor and like what parts of it to look for improvements for, right? And, if it was going outside of the computer, right, a network call, then that might be something that you'd want to focus on first in terms of, caching it locally, because you're going to get a much larger return on that investment. And here it is in numbers. If you're going across the internet for that request, it's 300 million times slower than the L1.
Yep.
Yeah, and so a lot of ways, this is really sideways to the whole caching conversation, now that I think about it. But it does show you just how important these numbers are and how important caching is, because it lets you avoid a lot of these bumps, which really do have astronomical figures. I mean, I just looked it up. Earth is roughly 365 million miles away from Jupiter. So if the L1 cache is 1 mile, then the internet is Jupiter, which I can't even see. Right?
Right. Without
it's
a telescope.
huge.
Yeah.
It's the biggest planet in our solar system.
Well, if you can't see it, does it still exist? I mean,
I'm doubtful.
yeah, I'm going to have to question that. I think somebody drew something pretty.
Hey, but you had the more relatable terms too.
Yeah, and so this is probably a much better, much easier way to talk about this. So we probably should start with it, maybe. I don't know. But somebody translated these numbers to times that are actually like, something I can deal with as a human being. So if we said that the L cache was 1 second,
The L1 cache specifically.
L1 cache, the smallest unit of time here we're talking about is 1 second. Then we're talking about 5 days for RAM.
That's crazy.
Yep. That data center that we're all amazed is so quick is 11 days.
And that was for the network access within the same data center.
Yep.
Solid state, roughly 4 times faster, 23 days. So we're almost up to a month.
That's it. I'm definitely returning that 950. That's done.
Yep. Well, hey, you know what? Any SSD is going to be a lot better than 15 months for a spinning drive.
You know what? I'm done with computers. I'm just turning it off.
So we just jumped from 23 days for the SSD to 15 months.
That's
over
sick,
a year.
right?
Wow.
But he hasn't even gotten to the grand finale.
Yes.
No, that packet that went from California, Netherlands back, 10 years.
The internet's.
Yep.
Wow.
Yeah, so that's incredible. And those really are just astronomical numbers. So, yeah, if you can skip those internet calls and hit memory instead, and even better, if your processor can get the information it needs out of those L1 and L2 caches instead of memory, then it's just incredible. It's amazing how much time you can save.
Yeah, that's really cool.
Yeah, and with those kind of numbers, it's not so much about performance. It's a matter of whether you can even do it at all. We're not talking about this, your app behaving slowly or not when we're talking about, 150 million times slower. We're talking about whether something is doable at all.
Yeah, totally. Yeah, I don't see it in our show notes, but I think we should talk a little bit about, so we just talked about the differences in the speeds between L1, L2, RAM, SSD, spinning, all that. But what makes it work, right? Like the processor has these algorithms built into them so that they know how to put things into the cache and then get things out of the cache. And then when something, there's, what's it called?
But
It's
for
like
L1 and L2 or 3 and 4. But when you get into RAM or SSD, that's not the processor.
No, it's not the processors, but I'm talking about specifically about the on-die, the L1, L2 stuff, right?
Okay, sorry.
So that's algorithms built into that. But the whole point of the cache is it's only useful as long as it's keeping stuff that needs to be accessed a lot, right? So if you're putting things into it, you want to put things that are most relevant, that need to be accessed the most. Those need to be on your L1, right?
Well, now we're getting into like the different algorithms for caching.
Yeah, we're not going to talk about the algorithms, but I just want to, like, we talked about
we
the
are
speeds
in an upcoming episode.
in an upcoming episode. That's why I don't want to get too deep into it. But I think to put it into perspective, we need to understand, okay, so L1's fast, but okay, cool. I mean, what does that mean? Does that mean that, I guess the flow of it's kind of important. And I think, Joe, you had a link.
Yeah, I've got a couple of nice links that we're going to have in the resources we like section. You're talking about the visualization?
Yeah.
We've got one cool one, and what it is a bunch of blocks that represents the L1 cache, the L2 main memory, and hard drive. And you can click each of these boxes, and it gives you like a little floating square that shows you how fast it takes to travel from that location to the processor, and actually will flow through each. So you click on L1, it's almost instant. L2 flows to L1 a little bit faster. Main memory, noticeable 2 than 1 than CPU. But man, when you hit that hard drive, it really hits home just how slow disk access is.
And for those following along in the show notes, this is the overbyte.com.au link that you'll find that has this fun little cache example that he's talking about.
And this, I've been clicking on it for 15 minutes now.
It's addictive, right?
I really, it's cool to watch. I mean, seriously, it is one of those stress relievers. But
yeah, and one thing I read a little bit about caches because I still have a hard time really understanding what goes on in the processor. That's kind of like college stuff that we read about, took the test, and forgot about. But what some of the examples I saw for like what kind of things happen in L1 cache that's really good at is stuff like for loop, so incrementing the indexes, stuff like that, numbers that it takes and increments and caches or stores again and repeats and things like addition and things that just computers are fantastic at. Those kind of things do great in those caches because they go in there, they stay there, you operate on them, you put them back, you take it back into the CPU, add another one, drop it back in, do some, conditional anding, oring, even like string comparisons where you're comparing two sets of binary to see if they match. Like those things are just fantastic for cache. They just fly right through.
Yeah, and the important part of this whole cache thing that I really wanted to touch on without going into any specifics this go around is the L1 is right there for the CPU to grab stuff from just as fast as it possibly can, right? So it can get and put to there as fast as it wants. The L2 is where you're going to have things that maybe aren't accessed quite as much as what's in the L1. So that's why it's your L2 cache. So things get put in there, and those are probably hit a lot. In one of the articles that I think both Joe and I had read were from Extreme Tech, and it had a great explanation of this. Is the whole point of cache is when the CPU goes to grab that data, it needs to get a hit most of the time. Whether or not it gets it from L1 or L2 is somewhat irrelevant, but the point is the more you can have in cache, the faster it can operate. And so that L1, stupid fast. The L2 is also incredibly fast, but we already said it's 14 times slower. But if you can get a good 90% hit rate of everything that processor needs in one of those first two caches, you're screaming along. As soon as you get outside those two caches, now you're going into memory, where a lot of stuff is cached there as well. But now you're talking about orders of magnitude slower. So anytime it misses a hit in one of those two caches, it's having to go to way slower memory spots to bring that stuff in. So the flow of this is super important. And that's kind of why we went through all this, was to describe things that maybe we don't think about much.
Yeah, and so in this episode, we wanted to give you a good baseline for what these numbers are and what they mean and what they mean and how we can speed things up by kind of skipping around and playing some tricks. But in an upcoming episode, we want to talk about things like application caches, like things like your frameworks, like say Node or ASP, how that factors in, what SQL Server does with memory, and how it speeds things up by kind of keeping stuff in RAM instead of disk. Some tricks for local hard drives, some things that they play with. Caching servers, even like the WordPress site we use has super cache plugin, something or other that just basically prevents extraneous processing, right? So there's all sorts of different reasons for caching, and we want to talk a little bit about some of the algorithms that we use to kind of maximize the benefit and minimize those misses, and some data structures, and just some other cool stuff. But we wanted to kind of go here from a bottom-up approach so we could have a good baseline for talking about it in our next episode or one of our future episodes.
Yeah, totally.
All right. So with that, maybe we should get into Alan's favorite part of the show. It's the tip of the week.
Hey, we're actually closer to week than the last, 12 episodes.
I mean, I don't know why you got to judge.
All right, so who's up first this go around?
I think that's going to be Joe.
Yep, I woke up at 6 this morning and I put my show notes in. It was terrible.
Wait,
Ugh.
what?
Yeah, I woke up too early and, it was either play a video game or do my show notes. So
Wait. Seriously. You get, if you wake up in the morning, you'll put on a video game?
Well, I mean,
yeah, man.
If you're going to be awake, you might as well play, right?
You don't just lay there in misery hoping to go back to sleep?
No, man, I got to get the dogs out first thing. So if I wake up or they wake me up and they need to go out, I don't want any accidents. And once I'm up, man, I'm up.
Wow. Wow. Okay.
Now you know why I'm falling asleep
you
on
have
late recording
kids,
nights.
dude. What are you talking about?
Dude, my kids somehow make it to school. I'm not sure how. I have kids. They somehow get to school. No, I mean, seriously, like if I wake up at like 5 a.m, I'll just be mad about it for 2 hours. I'm not going to get out of bed. I'm going to lay there and be mad about the fact that I'm not sleeping till 7.
Yeah. Yeah,
Oh,
in
man,
fairness, I'm kind of
time.
the same way. In fairness, I'm the same way. If I'll just, if I could sleep, then like I really think that Sleeping Beauty had it right, where she could just like spend her life sleeping. That sounds
love
like
to sleep.
It wouldn't be such a horrible thing, But even today, by the time my boys had left for school, well, I was up. They just didn't see me, and then
You hid from them.
No. It wasn't like I was hiding from them. I was just, up and doing my thing, but they didn't see me, by the time they had gone downstairs. And so when they did see me, I was coincidentally walking downstairs, and my oldest is like, "Hey, did you just wake up?" I'm like, "Thanks." Thanks. Wow. Tough crowd.
All right, so you woke up, you put the show notes in. What'd you throw in here for this thing?
Oh, yeah. Sorry. Sidetrack.
Yep. So this is an audiobook I just listened to that was really good. It's been the author's been making his rounds on a couple of podcasts, so you probably heard some snippets or at least him talking about a few things. If you listen to shows like Reply All or maybe Invisibility, Note to Self, I forget where all he's been and where I've heard it. But anyway, he takes a bunch of computer science problems and algorithms for solving those problems and applies them to real life. And the book is called Algorithms to Live By. And he uses things like, he'll talk about like the traveling salesman problem and talk about how that might apply to, say, finding your life partner and dating and the halting problem, when to quit, how to organize your sock drawer. Talks about sorting algorithms, talks about caching, talks about just all sorts of computer science, like hard computer science problems, and applies to those to all sorts of things in real life. Even finding the best parking spot, or not necessarily the best parking spot, but at which point you should just give up and take the next one you see. And it's just a really interesting quote unquote read. And I think that if you like the show, you're gonna love this book.
It sounds stressful to me.
No, it's fun because it's computer science algorithm. He describes the problem and then talks about how you can, apply it to your closet or sock drawer or, bookshelf.
All right. I will probably pick this up.
And what's awesome is that a lot of times it's the laziest approach. So, for example, the bookshelf idea, if you've got something like, say, a file, a file drawer, something, papers, receipts, something like that, rather than sorting those things, you might as well just put them on top of the pile. Whenever you need one, fish it out of there, put it right back on the top the pile, because you're more likely to need things that you've looked at recently. And so older things will kind of find their way down to the bottom of the pile. And the newer stuff and the stuff you're actually dealing with more often is going to be on top. And this is actually the most common caching strategy, which we'll be talking about soon for LRU, or least recently used, where items that aren't accessed often, and they drop out of the cache, and the stuff that you're doing more often just kind of sits at the top. So don't organize your drawer. Don't organize your files. Yeah, all these years I've just been hyper efficient.
I feel like these may be great things to improve your efficiency in life, but also decrease your spouse's approval of how you do things.
No, am I remembering this incorrectly? The traveling salesman problem, if I remember right, that one is, there's technically not an answer for it. It's like so hard.
Yeah.
Oh yeah, especially
it's
like
impossible.
when we're talking about large numbers. Like that's the one that it's
they've gotten very good at trying to come up with decent solutions, but there is no truly correct answer for it.
Yeah, I mean, this is why like Google Maps does a good estimation of it, but especially as the distance and the number of places grows, then it becomes
exponentially harder.
Yeah, it's exponentially more difficult to solve the problem. And in fairness, maybe this is why Apple Maps isn't so good.
Yeah,
because it can't handle more than 3 points on a map.
I don't know. Maybe it's 2 points.
Yeah. Well, actually, a huge portion of the book is dedicated to problems like that are basically exponentially. They're problems that are hard, if not impossible, to solve perfectly. However, if you take a rough approximation, if you do one of these computer science-y algorithms that's used to dealing with uncertainty in real life situations, then you can dramatically improve your results. And so the traveling salesman problem is it's NP. It's not solvable as far as anyone can tell without going just brute force and looking at everything. However, you can get pretty damn good by looking at a small subset of data. And the book dives into all sorts of things, all sorts of problems like that, like dating and when to stop looking for a partner and just take the next best one. And it won't necessarily find you the best life partner. but
wait.
chances are it'll be pretty good.
So the most direct solution would be for the traveling salesman would be to try all permutations, right?
Yep.
And then if you go that approach, right, in big O notation, it's a polynomial factor of O to the n factorial.
Oh,
Right.
good Lord.
The factorial of the number of cities that are involved, right?
Wow.
And one of the earliest applications of this solved the problem in O of n squared times 2 to the nth.
Jeez,
Yeah, it's
dude.
horrible.
That's a lot of processing.
Like this, it's considered. You said NP, but it's an NP hard problem. Yeah, that's the one I was thinking of. It's
Hey, but wait a second.
There is no answer.
We need to go back to something that Joe just said right there.
sorry.
No. That's impressive information. But can you imagine you're having to talk with your future, partner, and like, hey, do you remember how we met? Oh, totally. Like the first three just weren't, they were too hard.
Yeah. Well, what's funny is humans naturally kind of do this. That's what you do when you're dating, right? You date a few people when you're younger, and at some point you get around marriage age, and it basically, those first couple are gone, right? Those bridges are burned. There's no going back. So you end up kind of, wait, I don't know that I should continue.
I feel like this needs to be burnt to the ground before the ground before anybody.
No way, man. We are
love-
finding out just how romantic Joe is.
Yeah.
And I think there's value in that.
Man,
Yeah, and the
what?
magic number is 37%. You should basically date 37% of what you think your entire dateable pool is, and then just pick the next one that's better than any of those you've dated before, and done.
Oh my God, this is amazing. By the way, I have a feeling we're going to be the cause of a few car accidents because people are going to they have to laugh about this. Like, this is, wow.
Yep.
All right, so I guess I'll follow that up with my tip of the week, which is not nearly as interesting as Joe's 37%.
No, 37%
Of your-
just
of
to
your-
find the next that you need to drop down.
Well,
to.
it was of your dateable pool. It was 37% of your dateable pool.
Oh, that's amazing.
I think I had the number right. I could be wrong.
Yep.
So let's say for example, have you ever found yourself in a situation where you get some text and it already has the non-printable characters in it where you can see like a code representation of that non-printable character, and you want to be able to see, you actually wanted something to translate that so that you get the actual thing. So let's say, for example, you have some text, a body of text, and it has a bunch of backslash n's in it for new lines, right? Mm-hmm. But you actually want something that would replace those backslash n's, right? Well, I found this great question and answer on Stack Overflow where you can use Sublime to replace those with the actual character that you want by turning on the regex search and replace feature in Sublime. And in my case, what I wanted to replace was get your propeller hats on and get ready for your keyboards. Ampersand pound XD semicolon ampersand pound XA semicolon.
They look like models of Scions, by the way.
They are. Those are definitely Scion models, the XA and the XD. But because what was happening in my particular case was, let's say if you were looking at within SQL Server Management Studio, and you're looking at the execution plan of some query, and there's one in particular that you wanted to look at, and so you, if you, unfortunately, you're like, let's say it was a store procedure that might have had a bunch of queries in it, and you're like, oh, here's this one problematic one. Which specific query is that? Let me just read that, right? But in the execution plan, you can't really see the query that nicely, and even on a large monitor, it could, depending on the size of that query, eventually truncate the text, right? So if you were to right click on where it shows like query number 10 of the batch, you can say show execution plan as XML, and it'll show you just you can see all of the execution plan, and you can find your particular query that way. And then as one of the attributes of one of the XML nodes, you can see the query. But then the query is munged, let's say, because all of the new lines and all the tabs and all of the non-printable characters are going to be translated into, XML safe text for the attribute, right? So that's where you're going to get these ampersand, pound, XD, semicolon, another scion. And so what was happening is, in my case, I wanted to be able to take that query and actually see which one it was, because in this was actually a really large stored procedure, so it had a truckload of queries in it. And I was trying to find like the exact one in the original stored procedure, and all I had was the execution plan as XML that I was trying to find it, that I was using to find it. And so this little Sublime trick turned out to be quite a nice way of getting it back to what the original was. So you could put ampersand pound XD semicolon ampersand pound XA semicolon in the find, and then in your replace, I could put \n\t, and it would actually replace it with a new line in a tab, which is what those original Scion characters represented.
Very nice.
Yeah, I actually do this daily with Sublime for all sorts of reasons.
I guess that means
I'm
Notepad. Oops, sorry.
Yeah, I think that just means I'm copy and pasting a lot of code around, which is not a good thing. Yeah, I do this all the time.
But you said you do it in Notepad.
Notepad++. I didn't get it.
Oh,
yeah,
okay, sorry.
So Notepad++, you could do the same exact thing. You can hit there's either a regex, or they also have an extended set, but you can do something similar. And I find myself doing that a lot.
Because where I thought you were going was just Notepad, and because what I have been able to do in the past with Notepad is if you can select the text, which may include non-printable characters, then you can use it as your find.
Right.
But you can't use it as your replace, because how are you going to type that in? And that's where this little trick using Sublime and or Notepad++, as you just mentioned, could help you out.
Yeah, that's beautiful. All right, so I guess mine now. This one kind of grew out of the fact that our show notes are usually a pain point. Like, we've had people ask us about, oh, you guys just record and then you publish. No, we don't. Like, we typically mix our tracks together and all kinds of stuff. Well, one of the pain points is always getting the show notes together, because if you've ever gone to our site or looked at the show notes on an episode, like, we really try and take, we go through a decent amount of effort to make sure that we're providing you guys with something that you can go to the show notes and actually go click a link and go look at the things that we talk about or whatever, right? So one of the things that we all sort of like is Markdown, because it's a real nice shorthand for doing this stuff. And I stumbled across this collaborative Markdown. So if you think of like a Google Doc where you could have 5 people in there messing around at the same time, I found this collaborative Markdown tool to where you could have 3, 4, 5 people in there doing Markdown on the same document at the same time. And that link is www.hackmd.io. So hackmedicaldoctor.io. And it's really neat.
Or Markdown.
Or Markdown, yes. Oh, by the way, somebody on Slack today shared an app on the Mac that is called Markdown. And I was like, oh, that's sweet. That's really nice. But yeah, this is a really cool little utility. It's free. You go online. You can either sign in as a user, or you can just say, hey, I'm a guest. It'll give you a URL that you can share with other people, and everybody could be playing around in the same document at the same time. And it's a pretty nifty little thing. So that is my tip for the week.
Yeah, and for those curious about if you want to get more meta about the show here for a moment, the show notes that you mentioned, we actually modeled that after the way broadcasters do their rundown for like a news program, right? So that's where the pain point that Alan, because we aren't using the expensive software that the broadcaster might be using, and so we're trying to mock that in Google.
Yeah, I mean the biggest problem is when you copy and paste out of like Google Docs. Sometimes it wants to carry along the HTML with it, and it turns into a nightmare, right? You end up spending an hour going through and doing this stuff. But I think we've actually found a way now to where we can do it fairly quickly, which means that we can give you episodes at the same 3-week interval that we always have, but it'll just be easier for us.
So it doesn't benefit them.
Yeah, not really, but
All
it's
right.
a cool utility if you ever need it.
So with that, be sure to subscribe to us on iTunes, Stitcher, and more using your favorite podcast app. And like I said before, be sure to give us a review. You can find some helpful links at www.codingblocks.net/review.
Yep, and you can visit us at codingblocks.net where you find our show notes, examples, discussions, and more.
And send your feedback, questions, and rants to codingblocks.net/Slack because they're much smarter than I am and much better at responding.
Joe, what we should have done here is tested Alan and just made him close his lid there on his computer because he said he had this portion of the show memorized. So we'll have to do that for the next episode. Let him do the closing since he has it all memorized.
Thank you for listening to Coding Blocks.
Now he's got his warning. He can study for the next few weeks.
That's right. There was one other thing. Oh, yeah. And so if you want the show notes for this episode, it's codingblocks.net/episode 45. So
That's it.
that is it.